right, section 7.2 is scientific notation. And today we're going to write numbers in scientific notation and in standard notation. And we're going to compare and order numbers using scientific notation. Now, just to give you a heads up, just give you a review, standard notation or standard form is just how you normally see a number, right? So rather than seeing 10 squared is equal to 100. 10 times 10, right? 10 squared is equal to 100. So 100 is how you normally see it, and 10 squared is not standard form. Does that make sense? Mm-hmm. All right. So you can use powers of 10 to write and compare very large or very small numbers more easily. Scientific notation is a shorthand way to write numbers using powers of 10. It's very important that you know this definition, so make sure you write it down. A number in scientific notation is written as the product of two factors in the form a times 10 to the n, where n is an integer, so your exponent is an integer, and that first factor, this a, is greater than or equal to 1, and it's less than 10. Okay, and then there are a few examples for you. So in the diagram that I like to use, this is something times 10 to the something. Something times 10 to the something. Where this first something has to be greater than or equal to 1 and less than 10. Okay? This second something tells you, that's the exponent, tells you how many times you're going to move the decimal, okay? And it tells you what direction to move the decimal. If it's a positive, you're going to move the decimal to the right, and if it's a negative, you're going to move the decimal to the left, okay? So the first something has to be greater than or equal to 1, and it has to be less than 10. The second something, 1 has to be a power of 10, of course, has to be a power of 10, and that second something tells you, or that exponent, tells you how many times and what direction to move the decimal. So problem 1 is recognizing scientific notation. Is the number here written in scientific notation? If it's not, then we need to explain why it's not. So here we have 53 times 10 to the 4th power. Is that in scientific notation? No, that's not. Why? Because what?
Because 53 is greater than 10.
Very good. Because that first something, that first factor, is greater than 10. Very good. How about letter B? Yes, that is in scientific notation. Okay, 3.42 is greater than 1, and it is less than 10, and my exponent, negative 7, is an integer. Okay? How about letter C? Yes or no? No, that is not scientific notation. Can you tell me why? Why?
0.35 is less than 1.
Very good. This first factor is less than 1. Why else? Jason? There's no exponent, right? It has to be a power of 10. Right. This has to be a power of 10. Very good. Problem 2 is writing a number in scientific notation. Writing a number in scientific notation. We want to see what is each number written in scientific notation. And when we do this, I want to start with b something times 10 to the something. Okay? Something times 10 to the something. Okay? Now, if you are starting with a very big number, what kind of exponent am I going to have? Positive or negative? You're going to have a positive exponent, okay? Because positive means you're going to move to the right. You're going to have a big number, right? So that means that this exponent is going to be positive. So we want to see where that decimal means. Where is the decimal to begin with? If you have a whole number, it's always at the end, right? So there's your decimal. And the decimal needs to be to the right of the first non-zero number in the number. Okay? What's the first non-zero number here? Huh? The first non-zero number in the number is 6. So it needs to be to the right of 6. So we want to move this decimal 1, 2, 3, 4, 5 places. See? So my exponent then is going to be 5. And my first factor, my first something, is going to be 6.78. You get it? All right. Very good. For letter B, we're going to start with, again, something times 10 to the something. Something times 10 to the something. Now, we're starting with a small number, okay? Starting with a small number. Is my exponent going to be positive or negative?
Negative.
Negative. Very good. And where does the decimal need to move to?
3.
After the 3, because that's the first non-zero number in the number. So it needs to be right there. So 1, 2, 3, 4, 5 times. So my exponent then is a negative 5. And my first something is, very good, 3.2. All right, and here are the answers for C and D. Problem 3 is writing a number in standard notation. Now, we just did standard to scientific. Now we're doing scientific to standard. So it's going to go, the moving is going to be in the opposite direction. Okay? So here we want to know what is each number written in standard form. Okay. So when we do this, we're going to start with our first something. Our first something here is 5.23. Our second something, 7. It's a positive number. Okay? It's a positive exponent. So if we have a positive exponent, am I going to end up with a very big number or a very small number? A very big number. So if I want to have a big number, am I going to move my decimal to the left or to the right? To the right. Very good. How many times am I going to move it? 7 times. Awesome. So 1, 2, 3, 4, 5, 6, 7. And what do I do with those? You add zeros. Okay? Now you're not done yet because I want you to rewrite it with commas. Okay? When you have the big numbers, I want you to rewrite it with commas. And when you put the commas in the number, We start from the back, not the front. Okay? So this is going to be 52,300,000. Got it? For problem B, we have 4.6 times 10 to the negative fifth. Am I going to end up with a big number or a small number? Small number. Why are we going to end up with a small number? Because we have a negative exponent. Very good. So we're going to start with our first something, which is 4.6. And we're going to move that decimal. Which direction? Left or right? To the left. How many times? 5. 1, 2, 3, 4, 5. And of course we're going to add our zeros. Do I put commas in this number?
No.
No. Very good. So we have 0.000046. Anybody? Can anybody read that? So here are the answers for C and D. Very good. Now, part E, how do you write a number in the form A times 10 to the 0 in standard notation? How do you do that? Trevor?
If we just say it so, because it's 1.
Very good. It'll just be A. Because 10 to the 0 is 1. So A times 1 is A. And also, 0 means we're not moving the decimal at all, right? We're not moving the decimal at all. So it just stays A. Good. So problem 4 is comparing numbers in scientific notation. We want to know what is the order of the following parts of an atom from least to greatest. From least to greatest. Now, when we are comparing numbers in scientific notation, we need to make all of the exponents the same. Okay? We need to make all of the exponents the same. Let's write that down. So, which one of these is the one that I need to change? I need to change the electron. Here, this is negative 28. They're all negative 24, negative 28, negative 24. So we need to make this one, the middle one, into a negative 24. How do I make negative 28 to a negative 24? You're going to add 4. Very good. So we're going to add 4. Now what do you think happens if I'm going to add 4 to the exponent? What happens to my first factor?
Doesn't have to move over
To the
left.
To the left. Very good. You're going to take this decimal and you're going to move it 1, 2, 3, 4 times to the left. Okay, and then of course you're going to add your 0. Oh, no 0 right there. Then you're going to add your zeros. Okay, so 1, 2, 3, 4, you add your zeros. So, here is your number. All right. So if you add to the exponent, you move the decimal to the left. And of course, conversely, if you subtract from the exponent, then you're going to move the decimal to the right. Okay? Now, once you have all of your exponents the same, negative 24, negative 24, negative 24, then you just compare your first factors. You see that? So then you just compare the first factors. Let's write that down too. So once your exponents are all the same, then you're just going to compare the first factors. So going back to our problem, now we can answer it. Which one is the smallest?
Electron.
The electron is the smallest, so that's the first one. Then we have the proton, number 2. And then finally, number 3 is the neutron.
7.5.